Hello everyone, welcome to our online video tutorial series, and today we'll discuss about class 11 topic relation and functions part 2. In the previous video, dear students, we learned about the Cartesian product between two sets. In this video, we will learn about the relation and its properties. So first, let's understand what do we mean by the word relation. So let's take an example of Cartesian product from set A to B, where set A is having the elements A, B and C, where the set B is the set of the some names Aman, Binoy, Ashish and John. Then Cartesian product from A to B will be first A with the letter A with Aman, then A with Binoy, A with Ashish and A with John. Similarly, we will relate this element B with all these four and C with remaining four. So total how many elements we will have? This set A is having three elements. Number of elements in set A is 3. Number of elements in set B will be 4. And number of elements in A cross B will become 3 into 4, that is 12. So we can check that we have the 12 ordered pair here. Okay. Now let's relate the letter in the first set with the names in the second set which start with that letter. That means like Aman starts with A, and then Ashish starts with A, then Binoy starts with B, then no other pair I can see that. Okay, that's it. So only these three pairs in this Cartesian product are such that they are associated with some property that first set with the names in the second set which starts with that letter. Okay, so remaining does not satisfy these property, these conditions, so they are not in that relation. So if I list only these three ordered pair that satisfy the condition, so it become our relation. That means relation is what? Relation is something in the ordered pair where elements from these two sets are associated by some common property. Okay, and this way of writing the set relation is known as roster method, as we studied in the set theory also. This is known as the roster method. Then if I represent them by using this arrow diagram, so set A having the coordinates A, B and C, and set B having the elements Aman, Ashish, Binoy and John, if and I join them with that relation, A will be associated with Aman, A will be associated with Ashish and B will relate with Binoy. So this way is known as the arrow diagram to represent our relation. What is this method? This is arrow diagram. And third way is we can represent them by using set builder form, a rule method, property method. So what is that property method, a set builder form? See, our relation, this set consists of the ordered pair x and y. X is the first letter of the name, and then we have to tell name y. Then we have to tell that x belongs to set A and y belongs to set B. That means we have to select this x from the set A and this y we have to select from the set B. Likewise. So this way of writing a relation is known as the set builder form or rule method. So this is a, again same example I have taken. Set A having the coordinates elements A, B and C, and set B having the elements these four names. So let's make the Cartesian product. So Cartesian product will have these 12 ordered pair A cross B. Now as you know, these three ordered pair are in the relation. So this is a relation. What insight I got from here, that relation is a part of this Cartesian product. That means I can say that relation is a subset of a Cartesian product. So relation is always a subset of Cartesian product. Then how many relations can be defined from a set A to set B? Let's see. First of all, we will check that the total number of relations that can be defined from set A to set B is the number of possible subsets of A Cartesian product with B. As many possible subsets we can make, that many relations we can make. From here I got that idea that as many subsets of A cross B is possible, that many relations we can make. So let number of elements in A is P and number of elements in B is Q. Then A cross B will have PQ elements, and how many subsets are possible then? Yes, 2 raised to power PQ. So total number of possible relations will become 2 raised to power PQ. So let's define the relation now. A relation R from a non-empty set A to a non-empty set B. That means first thing that A and B must be two non-empty sets. Is a subset of the Cartesian product A to B. So relation is a subset of Cartesian product A to B. The subset is derived by describing the relationship between the first element and the second element. That means elements of these two sets must be associated by some relation. So some relationship must be there. Okay. In the second element is called image of the first element. So here Aman is the image of the first element A. Similarly, Ashish is the image of A. Binoy is the image of B. And these A and B are known as the pre-images. John do not have any pre-image. So A and B, these elements of the first set are known as the pre-images, and elements of the second set are known as the images if they are associated in that ordered pair. The set of all elements of the ordered pair in the relation R from a set A to set B is called domain of the relation. So this set, whatever is the pre-images, these are the domain of this relation. So domain will include A and B. So these are the first elements of the ordered pair of the relation. And the set of second elements in a relation from set A to B is called range. So here you have to notice it very carefully, dear students, that set of the second elements of the ordered pair. See, John is not a part of our ordered pair here in that relation. So only these three will be the elements of range: Aman, Ashish and Binoy. Because John does not comes under the that ordered pair which will satisfy that relation. So this will be the range. And altogether the second set is known as, the set B is known as the codomain. This complete set B is the codomain. So codomain is having four elements: Aman, Ashish, Binoy and John. Whereas if I am talking about the relation, so only these three set elements are the images. So set of these three elements is known as the range. So you can check that this set of range is a subset of codomain. So range is a subset of codomain. So let's solve some problem. So here A is a set 1, 2, 3 up to 14 and defined a relation R from A to A, means first element will belong to A and second element will also belong to A. And what is the relation? Relation is between X and Y such that 3x minus y is equal to 0, means y is equal to 3 times of the x, where x and y both belongs to A. What is this method in which we had written this? This is known as the set builder form. So let's start. If I take x, from where I have to take x? X we have to take from A. Let's take x is equal to 1. So let's write the relation in the roster form. If I take x is equal to 1, then what will be the value of y? 3 into 1 minus y is equal to 0. So y will become 3. So 3. If I take x is equal to 2, then y will be 6. X is equal to 3, then y will become 9. X is equal to 4, y will become 12. X is equal to 5, y will become 15. But we will not select this pair. Reason is x and y both must belongs to set A, and set A is having the numbers up to 14 only. So here y is equal to 15 is not in our ordered pair. Okay, what is the domain of this relation? Yes, it is 1, 2, 3 and 4. What is the range? Range is the second elements of the ordered pair. So 3, 6, 9 and 12. And what will be codomain? Codomain will be the all the elements of the second set. What is the second set? Second set belongs to Y belongs to A. So all the elements of A. What is A? 1, 2, 3, 4 up to 14. So this is codomain. So range is a subset of codomain. Define a relation R on the set of natural numbers, and where relation is between x and y, where y is equal to x plus 5 and x is a natural number less than 4. X and y both belongs to natural number. So let's decode this. X and y both belongs to natural number. First thing. Second thing, he says that x is a natural number less than 4. So if x is a natural number less than 4, then what are the values of x possible? 1, 2 and 3. X is a natural number as well as it should be less than 4. So x can have the values 1, 2 and 3. Okay. Now what is y? Y is equal to x plus 5. So if x is equal to 1, y will become 1 plus 5 and that is 6. If x is 2, y will become 7. X is 3, y will become 8. So now relation will become 1, 6, 2, 7 and 3, 8. So what is domain now? Domain is 1, 2 and 3. What is range? Range will be second elements of the ordered pair, that is 6, 7 and 8. Here A is 1, 2, 3 and 5, whereas B is 4, 6, 9. We have to define a relation R from A to B such that XY is the ordered pair where the difference between X and Y is an odd. That means only those ordered pair will come in the relation if their difference is an odd number. X we have to select from the set A and Y we have to select from the set B. Okay. So this is the relation. A and B are given. So let's write down. So we know that when the difference will be an odd number, the difference will be an odd number if I take one number as even and the other as odd. So if I select 1 from this one, then I have to select 4 from the second set. 1 with 6, their difference will be an odd number. But 1 and 9, two odd numbers, their difference will become even number. So we will not write that. Then 2, if I am taking this even, then from this set I have to select an odd number. So 2 with 9. Then 3 is an odd number, 3 with 4 and 6. 5 with 4 and 5 with 6. So that is the way we can write the relation. So here is a figure given between the sets P and Q. Write this relation in set builder form, in roster form, and we have to write its domain and range. So observe this picture carefully. So set P is having the elements 5, 6 and 7. Set Q is having the elements 3, 4 and 5. Okay. So when we observe that every element of P which is associated with Q in such a way that P is 2 more than Q. Or you can say that Q is having the value 2 less than elements of P. Similarly, 6 is associated with 4, that is minus 2. 7 is associated with 5, again minus 2. So, you can say that elements of P are 2 more than elements of Q. Correct? And this can be written as that relation between X and Y where X is 2 more than Y. X we have to select from the set P and Y we have to select from the set Q. So if I write in the roster form 5 with 3, 6 with 4 and 7 with 5. And what is the domain now? Domain will become 5, 6 and 7. First elements of this ordered pair 5, 6 and 7. Range will be 3, 4 and 5. So here A is 1, 2, 3, 4, 6. R is a relation defined on by this relation. So let's first interpret this relation. What does it mean? So relation is in between A and B. Okay. And A and B both belongs to set A. That means we have to select both the values from this set. 1 set A, 1, 2, 3, 4 and 6. Then B is exactly divisible by A. and we have to write the relation between A and B such that this B is exactly divisible by A. That means A is a divisor of B. Okay. Then check that 1 divides, if I take 1 from this set, 1 divides 1, 2, 3, 4 and 6. That means all the elements of this set. Then 2 divides 2 and 4, 3 divides 3 and 6, 4 divides 4 only and 6 divides 6 only. So if I make the ordered pair, then 1 with 1, 1 with 2, 1 with 3, likewise 1 with 4 and 6, 2 with 2 and 4 and so on. So my relation will be like this. So here is the relation R between x and x cube. What does it mean? The first element will be x and second will be cube of the first element. X is a prime number. What is x? X is a prime number less than 10. Okay. X is a prime number less than 10. Then what value of x can be? X can be 2, 3, 5 and 7. So these are the prime numbers less than 10. So if first element is 2, then second element will become cube of 2, that is 8. If it is 3, then second element will become cube of 3, that is 27. 5, then cube of 5, 125, and 7 and cube of 7, that is 343. So this will be my relation. Next is set A is x comma y comma z and set B is 1 comma 2. Find the number of relations. So as you know, number of elements in A is 3, number of elements in B is 2. Number of elements in A Cartesian product with B will be 3 into 2, that is 6. Because this is equal to number of elements in A, number of elements in B. So 3 into 2, 6. So how many subsets? As we know, relation is a subset of Cartesian product. So how many subsets are possible of a set having n elements? 2 raised to power n. So if it is having 6, then if it is 6, then it will become 2 raised to power 6, that is 64. R is a relation between A and B, that AB belongs to integers. A minus B is an integer. Okay, we have to find the domain and range. So first thing, that A and B both are integers. So both are infinite set. So their Cartesian product will also be an infinite set. So A belongs to integers, B belongs to integers, and we know that difference of two integers is always an integer. So that means A minus B belongs to integer. So which means that every ordered pair of A and B will satisfy the condition of relation. Whatever integer A and B I select, their difference will be always an integer. So we can say that every A belongs to integer is the first element of the ordered pair. So domain will become set of integers, and every B belongs to integer is the second element of the ordered pair. So B also become the range, that is the set of integers. So that was all about today's class. Hope you enjoyed this. Thank you very much.